Okay, so we talked about multiplying together binomials and binomials, binomials and trinomials, and how we can apply that to larger ones that we didn't necessarily do, but that we can do. And now we're going to look at just some strange cases, some problems where they don't necessarily look like what we're used to seeing, but once you see what it means, you're going to see that it's really a lot more of the same thing. Okay, so taking a look at this example here, I'm asking you to do x plus 8 squared. So let me start off and show you what this does not mean. And this is a common mistake, so I want you to avoid this. Okay, so we say x plus 8 squared, and what a lot of people want to do for a problem like x plus 8 squared is give the squared to x, give the squared to 8, and try to turn this into x squared plus 64. Okay? And I'm telling you right now, right at the beginning, that this is not true. Okay? This is the exponent rule that everyone's thinking about are problems where if it looked like 8x being squared, I could say that this is 64 and x squared. And if you notice the difference, there's a big plus sign here, and in this one there's not. There's a multiplication symbol. This rule, this exponent rule that you learned about giving the squared to all of the terms, only applies to a product and multiplication. It does not apply to addition. Okay? So this is the rule that everyone's using. Okay, and they try to apply it to our problems here, but that is not true. Okay, so for a problem like this, what we actually need to do is expand this out. Right? We know a problem like this, if I said 3 squared, you would say, oh, I know that's 3 times 3. Right, so we're going to do the same thing. We're going to say x plus 8 squared really just means x plus 8 times itself. And now this looks like stuff we did a couple of examples ago where we multiply together binomial times binomial. So this problem is just going to be connecting together all the terms. X times x is x squared. X times 8 is 8x. And then I'm going to move on to the second term. 8 times x is also 8x. And 8 times 8 gives me 64. And now I can combine these middle-like terms. These 8x's become 16x plus 64. And so if you notice, there's a big difference between x squared plus 16x plus 64. Okay? And what we have up here that I said doesn't work. There's this extra middle term that we need to account for that doing just squaring the two terms doesn't get. Right? So we have to use this version where we expand out, and then we're going to get our answer. So let's take a look at a word problem, okay, so just to see how something like this could be applied in a different context. Right, so this problem is saying we have a square that has a side length of 2x plus 3. So let's draw ourselves a square. Right, there's a square. Okay, and we're going to say that it has sides of 2x plus 3. So there's a 2x plus 3 here. Okay, and we know it's a square, which means all of the sides are 2x plus 3. And I can put another one there. Okay, and they're saying that we're cutting a hole in this that's also a square. And so there's going to be a little hole here. Okay? And it says that hole has lengths of x minus 1. So we know that each of these is x minus 1, and also the width. Okay? And it's asking us to write an expression that represents the area of the remaining shape, which we call the shaded region. So if I were to see problems like this, the outside area like this might all be colored in, everything except for the hole. Right? So you might see something like this, where we're saying, tell me about the area of the shaded region. That's everything except the hole that we cut out. So for a problem like this, we said really what you need to do is find the area of the big square. Well, we can do that just by doing 2x plus 3 times 2x plus 3, which you may see for squares. Remember, the area of a square is side squared. That's the same thing as just saying 2x plus 3 squared. Right? So you may see it represented like this. Okay? But for our purposes, we can just multiply them together. Okay, so this is going to be 4x squared. When I do 2x times 3, I get 6x. Okay. When I do 3 times 2x, I'm also getting 6x. And when I do 3 times 3, I get 9. Okay. So it looks like the area, when I simplify these middle two terms, 4x squared plus 12x plus 9. This represents the area of the big square and the hole. So we need to find the area of the hole so we can cut that out. Right? So again, that's just going to be x minus 1 times x minus 1, length times width. Okay? And remember, that's the same thing. You'll see this sometimes written as x minus 1 squared. So we just need to do the double distributing here. It's going to be x squared minus 1x minus 1x plus 1, and the middle terms can be put together and turned into x squared minus 2x plus 1. Okay? So what we really need to do to find the area of the shaded region is take this first expression, that the area of the big square, let's subtract away the whole, and what's left over is the shaded region. So remember, those problems look like, okay, 4x squared plus 12x plus 9, that's one polynomial, minus x squared minus 2x plus 1. Okay? And we said when we do subtraction that really we want to distribute this minus into all of these. So instead it's going to be plus, x squared will be negative, this will be a plus, and the plus 1 here instead is going to be a minus sign. Okay? So we can say 4x squared plus negative x squared, well, that's going to be 3x squared. 12x plus 2x is going to be 14x. And 9 plus negative 1 leaves me with a positive 8. Okay, so I'm going to say this expression, 3x squared plus 14x plus 8, represents the area of just the shaded region, which is the rectangle with the